Alrighty, welcome back everybody. It's your main math man, Mr. Shen, coming to you live from Summit at Castro. In this video, still working through that Unit 5, still talking about some statistical analysis. And in this video, we're mainly going to be working with two-way tables. So it's another way to kind of organize, some data that you may have, and being able to, get some probability as well from it, by choosing different values from it. So we'll work with some fraction decimal percent. But in the first part, it says video two-way tables. We can organize data on two categorical variables by using a two-way table. A two-way table uses rows to represent one categorical variable and columns to represent the second categorical variable. Each cell of the table tells us how many data points fall into the particular intersection, and totals are often included at the end of each row and column. Watch the video walkthrough and answer the question. So if you want to watch the video that I have posted on there, go for it. Otherwise, I'm going to go over it as well to show you guys how to do it. So basically, it's up to you if you want to watch it or not. I originally was going to say pause the video and watch it, but if you want to just watch this one, you certainly can. So it says complete the two-way table using the data from the intro. So I tried to cut out as much as possible, so that way it was the lesson that we were doing for this one was still on two stable pages, because I have a bunch of crybabies saying, oh, it's too much, mister. It's fine. This will be quick and easy, so that way you guys are good. But it says some of the survey results are: the survey included 92 different students. 20 students said that they prefer Starry Night at the aquarium. 43 students said they prefer Sunset Lodge over aquarium. 47 students said they'd prefer Under the Sea over Starry Night. And 18 students said they prefer Under the Sea at Sunset Lodge. So what I can do is I can use some of the values that they have here, and I can fill in my table. So for example, it says the survey included 92 different students. So that's going to just be my grand total that I put down here. So that's the total. Again, that's going to be the bottom right. Then it says 20 students said they'd prefer Starry Night at the aquarium. Excuse me. So I'm going to say 20 goes with Starry Night and aquarium. So right here. And this is specifically the part that we skipped over. Is kind of gave you guys an opportunity, but it's like to set the scenario. It's like a prom night, and they're voting on different places and the theme for the prom. Now for the third part, it says 43 students said they would prefer Sunset Lodge over the aquarium. That's going to be a total. So we're going to put that Sunset Lodge over the aquarium. So those are two options. So we're going to put 43 there. 47 students said they prefer Under the Sea over Starry Night. So that is going to go right here. Again, we get that because it's saying that's the theme. And then 18 students said they prefer Under the Sea at Sunset Lodge. So that's a very specific thing. That's an example of an intersection similar to the 20. It's very specific. It's saying Under the Sea and Sunset Lodge. So 18 goes there. And so what you notice is, how can we get some of these values in it? So a couple of different ways you can calculate it. Again, you can do some simple subtraction. So for example, if we were trying to find the total number of students that chose Starry Night, we would do 92 minus 47, which is going to be 45. And that makes sense too, because if we were to add these two together, we would get 92 as the total. Then we can say for the next one, we can find out how many students wanted to go to the aquarium with the Under the Sea. Well, we would say, okay, well, we have the total Under the Sea, and we have the Sunset Lodge Under the Sea. So what we can do is we can subtract those two. So I'm going to do 47 minus 18 to get 29 students voted for the aquarium with Under the Sea theme. Then let's say I want to find out what the total number of students is for the aquarium. I would just add those two together. So I'd say 20 plus 29 is 49. And then the last box we have here, we need to figure out how many wanted Sunset Lodge Starry Night. And so a couple different ways. Like I said, there's several different ways. Like for this, actually for this one as well, if you wanted to do it, I could do 42 minus, or sorry, I keep saying 42. 92, I would say 92 minus 43 would also give me 49. So a couple different ways to find each of these, but as long as they're adding up carefully, you'll be good. But for this last one, we do 43 minus 18 to get 25. So I do 43 minus 18 to get 25. Then it says for number 2, it says, which options do you think the prom committee should choose? Explain your reasoning. So what we're going to say is this. We're going to say under the sea theme at the aquarium has the most total votes. So let's check that out. That's going to be compared to any of these values, so it's actually those 4 boxes. Out of those 4 values, 29 is the largest. This also satisfies, this will also satisfy the most people, since Under the Sea had more total votes than Starry Night, and the aquarium had more total votes than Sunset Lodge. So we're able to kind of use some inferences, or we're able to come to some conclusions using that two-way table. Then for the next part, it says high school graduate 6 months later. So you finally made it. You've graduated from high school. But what comes next? Let's look at some data to see what recent high school graduates are doing. The table below shows observational data about the education and employment of recent high school graduates. It is based on the nationally representative sample from the current population survey. Study the table and answer the questions below. So I'm going to switch to it in a second, but just some reminder on the vocab that we talked about in the previous lesson. We talked about how the sample is a part of the population. So you can make inferences or you can make conclusions from the sample based on that population. So we're trying to make some ideas or trying to get some ideas from that population by using that sample. So here's the two-way table that goes along with it. So it's talking about different employments when you are enrolled or not enrolled in school. So for number 1, it says what is the population for this table. So that's going to be what is the total. It says what is the population for this table. We're going to say that's going to be the recent high school graduates that are entering into these different situations. Then for number 2, it says how many people were included in the sample study. So that's going to be the total sample size is going to be 2,987. So again, like I said in the previous video, when you're trying to get a sample, I actually did that, nice. When you try to get a sample, you want to make sure that the sample is at least 20. Otherwise, it's not going to be a powerful sample size or a large enough sample size to give accurate inferences and conclusions about the population. Then it says for number 3, what are 2 categorical variables being studied in this table? We're going to talk about, what is the left side. Let me throw that up here maybe. Again, if you can fit it in there, anywhere works out, but this is number 3. It says college enrollment and employment status. So it's basically asking, what is this group on the left side? That's employment status, and then the top columns are going to be the college enrollment. Actually, let me just see if I can move this over just a little bit. I can squeeze it in to right here. Close enough. Or put it like right here. That's fine. Okay, for number 4, it says how many people surveyed are enrolled at a 4-year college. So we're going to say how many people are at a 4-year college. So I would say, I'd look at the column that says enrolled in 4-year college, and I'll look at the total. So we're going to say the amount that goes with that is going to be 1,348. Then for number 5, it says if you wanted to know the total number of high school graduates who were in the labor force, which boxes would you add together? So note the labor force includes both people who are employed and people who are unemployed and looking for work. So we're going to add together, let's see, what 2 numbers do we want to add here? We're going to say the people that are looking for work, so the total number of people that are looking for work is going to be 208, and the people that are employed, we're going to add those 2 values together. So it says the totals for employed and unemployed, which are the first 2 rows. Those are the totals that we're looking for. So we're saying 1,159 plus 208 is equal to 1,367. All right, then for number 6, it says write 1 question that you could answer using the information in this table. Mister, it says there's 2 parts here. What do I write? Just write 1 part. So it says how many recent graduates that are enrolled in a 4-year college are in the labor force, or you could write how many recent graduates that are not enrolled in college are also not in the labor force. So those are some questions that could be answered using that table. All right, so the next part kind of gives you some information on here. It says a relative frequency table. So the table below or to the side here shows the same data about recent high school graduates. However, it is organized differently to show the percentages of people who gave each response instead of just the number. So it's actually the same table, but they took the values and put it into a percent form. So it says this is called a relative frequency table. It is a type of two-way table that shows percentages rather than counts, meaning just numbers. It is helpful for seeing if there's an association between two variables. So kind of like we talked about in the previous video, we talked about correlation, causation. Is there an association as well with it? So let's answer some questions that goes along with it. So we're going to say same table. I'll just kind of move the questions down here. But it says the denominator used to calculate each percentage is 2,987. What does that represent? We're going to say that represents the total sample population. So be careful on the wording there. Again, we were saying that the a sample and a population are supposed to be different, but you can also say that's a sample size instead of population if you want to write that. But it's just the number of people that were polled or surveyed in this data gathering. For number 2, it says out of all recent high school graduates, what percentage are enrolled in a 4-year college and employed? So we're going to say we're going to look for enrolled in a 4-year college, so we're looking at this column, and we're going to look at this row since it says employed, so we're just looking at that as 11%. So I'm going to put that right there. I'm going to put that right above the and. So that way I can remember that it's two things. Again, it's the intersection of this column and this row. That is why they use that word intersection. Then for number 3, it says find the cell. Again, a cell is the specific box. Again, your rows are horizontal, your columns are vertical, your cells are the individual boxes. So it says to find the cell with the value 5%. What is the cell telling you? So we're saying, hey, right there is that 5%. It's going to be the percentage of not enrolled in school and unemployed. So 5% of those sampled are not enrolled in school and are unemployed. Then for number 4, it says what percentage of recent high school graduates are enrolled in a 4-year college. So that is just the total amount. And so actually, let me write, it is going to be 45%, but I want to kind of make sure we understand we're going to say it's 11%. Add these values together here. Let's say 11% plus 1% plus 33% is equal to at 45%. So that's what I would write right there. Then for number 5, it says if 3 million students graduate from high school in 2025 and these trends stay the same, how many graduates would you expect to attend 2-year college after graduation? So we're going to use the percentage from that. So what I'm going to do first, I'm going to say we have to add those values together. So I'm going to say let's do 6% plus 1% plus 10% equals 17%. I'm using that because I'm getting that from our totals that are on there. Again, I'm using that from that 2-year college. So I have to add those values together. And then what I can say is this. I can say, let me write this a little bit differently. Let's do 17% of, of like this, so that way you guys see what it looks like. Again, if you want to try typing this into Desmos, you certainly can. We'll do a little bit of Desmos work later. But we're saying, this is what it's going to look like for here. So again, I got that 70% from adding up the 3 values in the column, and I took 70% of 3 million, again that has 6 zeros, is 510,000, so that's 4 zeros. Moving on to the next part, it says playing with those percentages. So it says the table above tells you the percentage of all the recent high school graduates who gave each answer. But what if you want to focus on only high school graduates who enrolled in two-year colleges, or only high school graduates who are employed? So it says using that same data set, let's calculate a couple of percentages that will tell us more about those graduates. So for number 1, it says 1,060 recent graduates said they were currently employed. 228 recent graduates said that they were both currently employed and enrolled in two-year college. Out of the recent graduates who are employed, what percentage were enrolled in two-year college? So we're going to take it like this. Again, you can take it and type it in Desmos for yourself, but what we're going to do is we're going to take that numerator is going to be 228. We're going to divide it by the denominator of 1,060. Make sure you multiply it by 100 to get that percent, but we're going to say it's going to be 21.51%. Then for number 2, it says 507 recent graduates said they were currently enrolled in two-year college. 228 recent graduates said they were both currently employed and enrolled in two-year college. Out of recent graduates who are enrolled in two-year college, what percentage were employed? So very similar setup. Take the two values and make a fraction. So very simply, we're going to take 228 divided by 507, multiply that fraction. Again, make sure you do the fraction first, then multiply by 100 to get that percent. But we're going to say it's going to be 44.97%. Then for number 3, it says in the relative frequency table above, you saw another percentage describing the same group of 228 graduates. And it says 8% of all graduates said they were both currently employed and enrolled in two-year college. Why are these 3 percentages different? So this is going to be a little bit to write on, so make sure that you're just taking a deep breath. It'll be okay as you write this. But it says this, it says these 3 percentages are calculated using a different total group for the denominator. So that's why those change. Again, anytime you think of, fraction, decimal, percent, just think of pizza. That's an easiest way to be able to, think about it. If you're increasing the amount of slices you have, meaning the amount of times you cut the pizza, that's going to decrease the total size of the pizza. So if I'm increasing this denominator, the total percentage is going to decrease. So it says 8% use the whole sample as a total. So 228 divided by 2,732. And then it says 22% used employed recent graduates as a total, which is 228 divided by 1,060. And lastly, it says the 45% used recent graduates enrolled in two-year college as a total, which is going to be that 228 divided by the 507. Again, each of these values or each of these fractions are multiplied by 100 to get your approximate values on the left, or your approximate percentages. Then for the next part, this is represented in another way. So it says Mallet wanted to find out if educational enrollment was associated with employment. Using the same data set about recent high school graduates, she built a different relative frequency table to compare the percentage of people who were employed, unemployed, or not in the labor force across each educational group. So for number 1, it says, how is Mallet's table different than other tables we've seen for this data set? So we're going to say this. We're going to say the percentages are calculated using the column totals instead of the total surveyed population. So notice how the values change depending on what your denominator is. Then for number 2, it says out of all recent high school graduates enrolled in a 4-year college, 72% are not in the labor force. Make an inference. Why do you think that percentage is so high? So an inference, again, is almost like a conclusion. You're trying to predict something. You're making an inference. So it says many recent graduates enrolled in 4-year colleges are going to school full-time and do not have time to work. Then for number 3, it says out of recent high school graduates who are not enrolled in school, what percentage are employed? So I'm going to look at the graph here. So it says not enrolled in school and are employed is going to be 57%. All right, so now let's talk about the association. So associations between variables. So you learned about correlation in previous lessons. When we talk about two-way tables, we use the term association to mean something similar. So it says association refers to a relationship between two variables. When one variable changes, so does the other one. However, correlation is a type of association that tells us more about the shape and strength of the relationship. We can use relative frequency tables to determine whether two variables have an association. One of the easiest ways to know if there is an association is to work backwards. Check if the variables have no association. If there is no association, the relative frequency values should be very similar across each column or row. So part one, it says no association. So let's do an example for this. It says the table to the side here is an example of two variables with no association. It shows the percentage of American children with health insurance by age. You can see that the percentage of children with health insurance stays approximately the same in each age group. So let's hypothesize. Why is there no association between age and having health insurance? So there are three options here. I want you to write one. Mister, there's three options. What do I write? Just pick one option. So it says, for the first one, there are no major changes in the percentages of children with health insurances as they get older. In the second option, it says there are government programs that support children of all ages in health insurances. And then for the third one, it says children need consistent healthcare, so are equally likely to need health insurance across all age groups. Again, you can kind of think about that too. There's a whole division. I want to say pediatrics. Yeah, I think that's right. Pediatrics, or doctors that work with kids. You need frequent checkups, vaccines, or potential emergency cares when you are younger. And let me actually move this up a little bit so that we have a little bit more space. And then for number two, it says, how might the table be different if there was an association, if children were less likely to have health insurance as they got older? So let's kind of flip it around, but we can say this. It says, if there was an association, then you would expect some changes to occur between the age groups. Yes, you do have to write all this, but you should probably spell it correctly. It should say if, not elf, if. Okay. If children were less likely to have health insurance as they were older, you would expect the percentages with health insurance to decrease for the 6 to 11 and 12 to 8 groups, which is the two that are on the bottom here. All right, next part. So part two, association. So it says the table below shows the percentage of American adults with health insurance by education level. Study the table and answer the questions. So for number three, it says find the cell, which is the specific box, in the table with the value 93%. What is that cell telling you? So let's look right here. So it says 93%. That means that 93% of people that have health insurance also have an associate's degree. So 93% of those with an associate's degree have health insurance. So make sure you're careful on how you organize it, making sure that's written like that. For number four, it says based on this observational data, Owen concludes that there is an association between education level and having health insurance. What evidence from the table supports that conclusion? So making sure, again, our evidence for this one is the graph itself or the table itself. So we can say as education level increases, so does the total percent that have health insurance. And it says number five, imagine a law passed tomorrow that required everyone to complete at least an associate's degree. Do you think that would cause more Americans to have health insurance? Why or why not? We're going to say no. This table does not show that education causes increased health insurance rates. There are likely other factors related to people's jobs that impact whether they have insurance. You can talk about, benefits. You can talk about salary, union membership, maybe employer size, or what kind of industry they work in. All right, then for number six, it says make an inference. What is one other variable that you think could be related to either education or health insurance. So one inference we can make is we can say about industry, we can say about the number of employees, let's say about the union representation, salary, or that age. And then for number 7 it says review Mullet's relative frequency table from the previous activity. Is there an association between education enrollment and employment for recent high school graduates? Explain your answer. So I know this picture is not on your page, but I kind of brought it down so that way you can look at it here. But it says this, it says students who are enrolled in college are less likely to be a part of the labor force. Moving from not enrolled to 2-year to 4-year college, the numbers of employed graduates decreases. So they're talking about, as you move from these values, notice how that 13% decreases as you have more college. All right, so let's now apply it. So it says for number 1, this is probably test questions. The table below shows survey data about occupation and employment from the Bureau of Labor Statistics. What does the 90 in this table represent? So it gives you a bunch of information. We're looking for the 90. So I can say, hey, let's identify it first. We're going to say, hey, it's right here. So then it gives you some options here. I already know, hey, it's going to be a total number. So this kind of tells me, hey, it's percentage. That's not what I'm talking about at all. This is employment rate. That's not, or well, it also says percentage right here. So neither of those are percentages because this is not a percentage part at all. So make sure you can eliminate some options so that way you have it. Is that the total number of people surveyed? No, it is not, because that is actually the 185. So using that process of elimination, we're going to say it's going to be D. That is the total number of respondents in management and professional occupations. Then for number 2, it says use the two-way table below to answer parts A and B. So it gives you that same table. Then it says part A, complete the relative frequency table to find the employment and unemployment rate by occupation, and then round to the nearest tenth of a percent. So make sure after we change it to a percent, make sure you round that answer, comma 1. So I'll show you kind of what that looks like in here. So what we're going to do is very simply, let's say if I wanted to find out the percentage for employed, again, notice how it has the total percentage over here. So I have to add up to a total percent of 100%. So in order to do that, again, a couple different ways I can do it. If I wanted to do, let's say I wanted to find out what the unemployment rate is first, I can do unemployment rate divided by 90. So I'm going to do 2 over 90. I'm going to say times, I put a little star here, times 100 to equal that percentage. So let's check it out. I'm going to pull up Decimus here. All right, so on your Decimus calculator, let's find some values that we're going to put here. So I'm going to take, what was it, 2 divided by 90. Again, I can make that into a fraction. I'm going to multiply by 100 to get that percent. And I said I need to make sure, actually let's do it like this. Let's say, so we have our percentage here. So I'm going to take that value, and I click on it once, Control C to copy. To round, I type in the word ROUND, paste, comma 1 now, because I need to round to the nearest tenth, which is 1 decimal place, but it has to be as a percentage. So change it into percentage by multiplying by that fraction by 100, and then I can round comma 1. So what I'm going to put in here, let me change this over. I'm going to put in my column here, or my cell I should say, I'm going to put that 2.2%. So if I want to put a percent symbol here, I can, but it's not necessary. But now that I have this cell, I can do the same kind of thing. Instead, I can do another way of doing it. Let's say if I wanted to calculate the employment or employed percentage, I would take 88 divided by 90 times 100 to get that amount. I would round a comma 2, or another way of doing it is like this. I can say, well, I know the remaining percent is going to go in this box. So what I could do, I could take 100 minus 2.2, to get that percent, and that is going to be 97.8%. So you can, a couple different ways you can do it. Again, you can choose how you want to do it. You can calculate it using the fraction, or you can just subtract. Either way works. Same idea for the service occupations. I'm going to take, in my calculator here, let's do service occupations employed. So I'm going to say, let me pull up my Desmos again. So I'm going to say, in my calculator, I have the same denominator because I'm still at a 90, and I'm going to say service occupations is 42. Sorry, 42. And let me triple check to make sure that matches up. Oh no, not out of 90. My fault. That is out of 44 because that's going to be the value that we have here. So let me close this one. Let's me. This is going to be 44. There we go. Much better. Okay, so now I can take this value. This value is going to be rounded, comma 1. So that was my mistake. I thought I was keeping the same, but I cannot keep it the same because it is a different row total. So you got to make sure you're careful on that. Make sure you're doing the row total. So I'm going to change that to 95.5%. So let's go back to our paper here. So I'm going to plug in. I'm going to say, all right, that cell is going to be 95.5%, and if I subtract it, I can do 100 minus that 95.5, which would be 4.5%. And then lastly, let's do this bottom one. So let me erase this. Oh god, that's not erasing. This one's erasing. And I'm going to do let's do unemployed for sales, office, and occupation. So make sure you're changing that denominator now. So I'm going to do 6 divided by that 185. Let's do that on Desmos. So I'm going to say my numerator, I have 6. I'd recommend you do this with me so that way you can practice typing it in. And then in my denominator, I have 185. I'm going to take that value, round, comma 1, because I'm rounding to the 10th of a percent. So that's going to be 3.2%. So what they got, let me see. All right, so that 3.2%, that's going to go on that bottom part where the unemployed is. And again, you can subtract 100% minus 3.2 is going to be that 96.8%. Let me take that down now and make sure you're copying those values for your table. All right, now that we have the table filled out, let's come up with some answers here. So for part B, it says, is there an association between the unemployment rate and occupation, and explain your reasoning? We're going to say yes, the employment rate is higher in some occupations than in others. For example, 2.2% of people in management and professional occupation are employed compared to the 4.5% of people in service occupations. Make sure those numbers match up with what we were saying. Yep. And then for the next part, it says part C, which occupation would you say has the most job security? Explain your reasoning. And I think this one I have to change. Yeah, actually that's fine. It says for part C, management and professional occupations seem to have the most job security, as almost or nearly 98% of those in the occupation are employed. And I'm getting those values, from this table. Notice how this value is very close to 98%, but that's the percentage employed for that occupation. So that's why we're going to say that that is the most job security, because that means that you have a job. You can make sure you can ask questions as they come up. And as always, super slam that subscribe button.